So our last section for the June exam in algebra is graphs, and it's a huge section. So that'll be around about 40 marks of the 100 for your second paper, for your first paper. So the graphs contain all of the graphs from grade 10. How many graphs were there?
4.
Namely, straight line, hyperbola, parabola, exponential. But last year, you only did vertical transformations. You moved them up and down. Okay? This year, you're also going to do horizontal, the boys and girls from TRIP. Same principles. Okay, so even in the straight line, but I'm not doing that because you're not really needing it, but okay, that's my own opinion. Now, if I ask you, in all of them, you're going to have to do two things. With all four of the graphs, you're going to have to be able to sketch them and find their equations. Now, the straight line is old news. You've been doing it since grade 9. So, if I ask you to sketch a straight line, first of all, just please remember what is the general equation. And there's another one which you can use if you want. I'm not even going to mention it. But if you want to use it, and it's actually more for analytical geometry, but if you want to use it and you go for extra lessons and you want to use it, you're welcome. I'm not touching it. You can get by always saying y is equal to mx plus c. Where m is your radians and c is your y. Excellent. So if I ask you to sketch this, you actually already know that the y-intercept is 2. So if you have to go sketch it, put it there. Now methods, you were taught like 3 methods in grade 9. I'm not going to even touch on them. But the easiest method of ever drawing a straight line, sketching a straight line, is to find the x and the y-intercepts, because then you're done. So to find the x-intercept, what do?
Make y
equals to 0. For the y-intercept, x equals to 0. And in a parabola, same thing. Hyperbola, same thing. If you're needing an x-intercept, say for instance the x-intercept sits there, what is happening to y on that place where you've got your x-intercept? The y is 0. Wherever your y-intercept is, what's happening to x?
Also
0. That's why you're putting x equal to 0, because kids get lost and they think, what can I do? Where am I now? Let's just put x equal to 0 and y equal to 0, wherever you are. No. When you're doing that, you're finding x and y intercepts. X equal to 0 finds you the y-intercept, and y equal to 0 finds you the x-intercept. You must know what you're busy with, because it's going to happen in all the graphs. So if you do put y equal to 0 in the sum, it's going to be 0 equals negative 4x plus 2, which gives me a what? Linear equation. Excellent. So get the x alone. And the answer is 2 divided by 4, which is a half. So the x-intercept is a half. And the y-intercept, you could have worked it out if you'd forgotten that it's actually 2. But if you do go substitute your x with 0, what's your answer going to be? Anyway. So whether you say c is 2 or work it out, your y-intercept is going to be 2. But please remember, since last year as well, since grade 9, we are drawing sketch graphs. So you don't have to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's good enough. And I think just by a little bit of logic, this should be a little bit smaller. I'm not going to put the half there.
Yeah, true.
Okay? And then, let's start giving them some names. If I made this one fx, it's just for saying that is still y. You remember that fx represents y. And then on my sketch, I don't have to put the whole equation. I can say it's f, because it's got a name. Right, if I have to sketch a second example, and this example says y is equal to 3 over 4x. I'm also going to get x-intercept, y-intercept, right? That's what ma'am says to you. Best way of sketching is get the y and x-intercepts, but y-intercept is
0.
there it sits. Do you see it? And the x-intercept, if you put y equal to 0 and you work out your x, it's still going to be 0. So how many points have you got?
1.
The x-intercept is 0, the y-intercept is 0, you got 1.00. So where's the sketch? Okay, no big problem, no brain surgery here. All I need to go and do is find another point. Because on any straight line like this one, how many points are on this straight line? A lot. There's not just 2 points. I used 2 points to get the sketch, but it's got infinitely many points. So get me one. How? Substitute your x with anything, but please keep it here. So if we substitute, so we know that y-intercept is 0 and the x-intercept is 0. So how do we sketch this thing? We need another point. Any other point. So choose an x value. If I choose an x value here, like 1, then y will be equal to 3/4 times
1.
So what's the point I have? 1 for x and 3/4 for y. Where's that? 1 and 3/4, round about there. That's the point, 1 and 3/4. Can I use 2? Can I use 6? Can I use 7 million?
Yes.
Please don't. How do you want to sketch it? Are you with me? But these 2 little arrows tell me that it goes on until infinity. So 7 million will be there, but somewhere there in Pretoria. Are you with me?
Yes, ma'am.
Okay, but how many points are on a graph? A lot. Infinitely many. How many do I need to sketch a straight line?
2.
2 points, because then I can join them. If you got 3, it's even more accurate. But 2 is the basic that you need. Right. Then we also get special straight lines, which are vertical lines and horizontal lines. Then you don't use y equals mx plus c. Then you use the fact that in a vertical line, all of those x values will be equal to, and the y goes up to infinity and goes down to negative infinity, but all of those millions and trillions and infinitely many points, because how many points are from there to there? A lot. And up to infinity, even more, a lot. But all of those points vertically sitting there have an x value of 5. What's the equation of that straight line? That's it. Because for every single, what about y? Y could be whatever it likes. As long as x stays 5. So what's the equation of a horizontal line?
Y equals negative.
Think about it. Is it true? Each of those points have a y value of negative 2. The x can be positive lots, negative many things, but the y value stays negative 2. Gradient?
No gradient.
No gradient, it's 0. This gradient is something that you're going to now learn to do in analytical as well. This gradient in degrees is 90 degrees. But it's actually an infinite or an undefined gradient. We'll get there when we get to inclination. So, but the main important thing is to get equations, because you're going to use them. Remember the hyperbolas and hyperbolas and exponential graphs have asymptotes? Yes. And asymptotes are either vertical lines or horizontal lines, and that's where their equations come from. Okay, last thing for today. Parallel lines and perpendicular lines, not only in algebra, but also in trig, and also in analytical. So everywhere, the straight line is so important, because you get marks in both of the papers for it. Parallel lines, what do you know about parallel lines? What makes them parallel?
Yeah, the same.
They have the same?
Gradient.
Great. Gradient 1 is equal to gradient 2. Whatever the 2 straight lines are, they have the same gradient. And if they are perpendicular,
Gradient times together equals to
from last year, what does it mean? What does it mean? So if the one gradient is like minus a half, then the other gradient will be
positive a half.
positive
2 over 1.
Because remember, when you time them, they've got to give you 1, so they've got to cancel out. So if the one was minus 3 over 4, what must the other one be? Plus 4 over 3. And when you multiply them, you always have 1 as a minus, 1 as a plus, so you're going to have a minus. And they will cancel out and give you 1. So this is the principle behind perpendicular lines, and it must make sense, because remember, lines that do this have a what gradient? Negative or positive? You must know it. These are positive gradients. These are negative gradients. So in perpendicular lines, the one has to be positive and negative to make them perpendicular. So that's why it must be negative, because the one has to be plus and one has to be minus. That direction, to make them perpendicular. So let's just look at two examples quickly. Remember, this can appear in various ways whenever I'm busy with these lines. If I say the line F is parallel to a line G, then what do I know about line G? It has a gradient of?
1, negative 1 over 3.
What about the 2? Nothing. So no concern of mine, but all I know is that line has a gradient of minus a third. So my line must also have a gradient of minus a third if they are parallel. If they are perpendicular, same thing. So if I take that same F and I say, wait a minute, give me the gradient of the perpendicular line, then what will the perpendicular gradient be of minus a third?
Negative 3.
Plus
Negative 3.
3 over 1. Do I have to put it over 1?
No.
No, it's just 3. Plus 3 over 1, it's fine, but you've got to realize this whole thing about the one is the other one's inverse and negative. If it was negative, it's positive. If it was positive, it's going to be negative. Are you with me? Good.